Hi and welcome to this walkthrough of a thiosulfate iodine redox exam question. It's quite applied and it's from OCR Chemistry A F325 2015 paper question 7. So first let's have a quick check of what to watch out for in this type of question. The iodine in the thiosulfate titration will be a product of a previous reaction, and the previous reaction might itself be reacting products from an original reaction. So work backwards through the stages very carefully to keep track of the moles in the titration at one end, back to the moles at the original sample at the start. Let's visualize what's going on first. We're told that the 5.25 gram sample of chromite ore is heated, and it's heated with sodium peroxide, and water is added to the resulting mixture, and the Na2CrO4 dissolves in the water, forming a solution of chromate 2- ions. Then the mixture is filtered, and it's made up to a 1 decimeter cube volumetric flask, and a 25 centimeter cube sample of this alkaline solution is pipetted into a conical flask, and an excess of potassium iodide is added. So in the titration, you will get an average titer of sodium thiosulfate is 25.5 centimeters cubed, and now you have something for which you can work out the moles. So taking this information and just parking it for a moment, we can now start doing data moles equation moles answer. So the data is for the sodium thiosulfate at the very end, and working out the moles of that is 2.55 times 10 to the minus 3. Now in the equation you have a 3-to-1 mole ratio between S2O3 2- and CrO4 2-. This is carefully worked out by looking at those two equations or those two pieces of information. So thinking about this, the S2O3 2- is divided in half to get the moles of iodine, and 1.5 moles of iodine is further multiplied by 2/3 to get the moles of CrO4 2-. That is the 1.5 moles of iodine to 1 mole of CrO4 2-. So just going through that again, 2 moles of thiosulfate react with 1 mole of iodine, and that is a 1.5 mole ratio to a 1 mole ratio of CrO4 2-. So that gives us our 3-to-1 mole ratio. So therefore, multiplying 2.55 times 10 to the minus 3 by a third, that gives you 8.5 times 10 to the minus 4, and 25 centimeters cubed. And looking at our volumetric flask over here, it's 1 decimeter cubed, isn't it? So what we need to do is scale that up, 1 decimeter cubed being 1,000 centimeters cubed, divide that by 25 because it's a 25 centimeter cube sample, and that gives us 0.034 moles present in that particular sample. Now, you need to be careful here because we want the percentage mass of chromium in the ore. So the number of moles of chromium formed initially is the same as the number of moles of chromium in the FeCrO2 in the solid sample. So let's have a look at what we're talking about here. We've got an equation and we've got the chromate there, 4 moles of it. So there's 4 chromiums there, and that came from 2 FeCrO2. But that little 2 there, multiplied by 2 here, means there's 4 chromiums there as well. So it's a 1-to-1 mole ratio. So the number of moles of chromium in the solid sample is the same as the number of moles of chromate produced in the reaction, which is 0.034. Therefore, the mass is multiplied by 52 grams per mole, gives you 1.1768 grams, and dividing that by the original sample of 5.25 multiplying by 100 gives you 33.7%, giving our answer to 1 decimal place. Quick check of the mark scheme, you can see quite a lot of ECFs all the way through, and you can see where the ticks are actually awarded, similar to our calculations. If you get 33.7, you get 6 marks. There's some common ECFs you can double check there as well. Okay, so thanks for listening. Until next time, see you soon.